In these next couple of videos, we'll practice using our first derivative test to help us find local maximum and local minimum values of our functions. So let's suppose that I have the function f of x equals negative x cubed plus 12x plus 8, and I want to find the local extrema of this function. Before I do anything else, I need to think about the critical numbers. I need to find the critical numbers of this function. And if I'm thinking about critical numbers, I do want to think about the domain of this function. But the domain of f of x, I can look at the equation of f of x. This is a polynomial, so its domain will be negative infinity to positive infinity. The domain is not going to give us a big problem here. So I'm going to start by finding my critical numbers, which means I need the first derivative. So I need f prime of x. So f prime of x here for this problem, I can just use my power rule. I should have negative 3x squared plus 12. And for critical numbers, remember, I want to think about two different cases. I want to think about places where f prime is equal to 0 and places where f prime does not exist. So places where f prime is equal to 0, I'm going to take negative 3x squared plus 12. We'll set this equal to 0, and we'll solve for x here. So here in this problem, let's add 3x squared to both sides. So that means that 12 equals 3x squared, and then divide by 3 so that we have x squared equals 4. If I take the square root of each side, I end up with actually two separate critical numbers. I end up with a positive 2 and a negative 2. So x equals plus or minus 2. And hey, both of those are going to be in the domain of my function, so that's good to know. So there's the first part. The second part I need to think about is places where f prime does not exist. Well, I can look at the equation of f prime of x, and I can say negative 3x squared plus 12, that's a polynomial. So I'm going to make a note here that f prime is a polynomial. So that means that f prime exists everywhere, which means we don't really need to take anything into consideration here. Every time we have a polynomial, I will usually write this process out anyway, because I don't want us to forget that we need to think about places where f prime does not exist. When we're working with polynomials often, I think it's easy to kind of forget that that's a case that we need to consider. So I think it's just a good habit to always write that down and always be thinking about that, even if we are working with a polynomial. So okay, we have our two critical numbers here. We've got x equals positive 2, we've got x equals negative 2. So when I use the first derivative test, I want to know where does the sign of the first derivative change. And I'm actually going to use the process that I used in the very first example. I'm going to set up a little number line here. I'm going to say, okay, here on my number line for f prime, the two critical numbers that we found x equals negative 2, and we found x equals positive 2. So I'm going to also just make a note to myself, and this is just to kind of build up a good habit. Well, how did we find those? Why were those important? Well, we found those because at x equals positive 2 and negative 2, the derivative was equal to 0. And when it comes to problems that we'll be doing later on, when it comes to curve sketching problems, I do think it's really, really helpful to know what the behavior of our function at those critical numbers is. So I'm just going to put a little 0 right above those two critical numbers, because that's going to tell me when I get to sketching curves later on that, oh, I must have a horizontal tangent line. And sometimes I'll even make a note. We've got a horizontal tangent line at x equals negative 2 and x equals positive 2. But for now, I've got this number line here. I've broken it up into three separate pieces, and I'm going to take a number in each one of these intervals. I'm going to plug that into my first derivative, and then I'm going to use that to help me determine whether the first derivative is positive or negative. All I need to do is look at the sign, and then at the end of this problem, I should have everything I need to determine whether we have a local minimum or maximum value, or neither at these points. So my derivative, just so that we have it, my derivative here was negative 3x squared plus 12. I'm just going to write that down here. F prime of x equals negative 3x squared, and I already forgot, plus 12, right? Yes, plus 12. So again, I'm taking a number in each one of these intervals. I like to work left to right, so I'm going to start on the left-hand interval, and I'm going to choose negative 3. I'm going to plug that into my derivative. So f prime of negative 3, that would be negative 3 times negative 3 squared plus 12. So here, let's see, this will be negative 3 times 9 plus 12, which gives me, negative 27 plus 12. I should end up with a negative 15. And remember, it's really the sign of that number that we're after. So here we've got a negative on that left-hand side, so I'm going to put some minus signs over there on that left-hand side. Next, I'll choose a number in between negative 2 and positive 2. Whenever it's possible, I like to use x equals 0 just because it makes the computations pretty easy to work with. So f prime of 0, again, I'm plugging that into my first derivative. So we'll have negative 3 times 0 squared plus 12. Here we'll have negative 3 times 0 plus 12. 0 plus 12, well, that gives me 12. And in this case, we have a positive 12. So the first derivative is positive. I'm going to put some plus signs in between there to help me remember, oh, the first derivative was positive on that interval. Lastly, I have this right-hand side over here. I can pick any number between 2 and positive infinity. I'm going to pick x equals 3. How about that? So for that, I'm going to take 3 and I'm going to plug that into my derivative. So negative 3 times 3 squared plus 12. Negative 3 times 9 plus 12 gives negative 27 plus 12, or negative 15 once again. So it's a negative over here on the right-hand interval as well. So this is really, really helpful. Once I have this sign chart here, this completed sign chart tells me basically everything I need to know. All I need to do now is interpret this sign chart so that I can figure out where do I have a local minimum, where do I have a local maximum, or perhaps which one of these critical numbers is neither a minimum nor a maximum. And what I like to do for these types of problems is I like to draw in the behavior of the graph. I think that's very helpful in remembering and identifying whether we have a minimum or a maximum. So here we had the first derivative was negative. That means my function is decreasing, it's going down. Then we had the first derivative was positive, so that means my function is increasing, it's going up. And then after that, on the right-hand side, my first derivative was negative again. It's decreasing. My function is going down. And I can sort of sketch in a little graph if I want to, and I think it makes it a little bit easier to see, oh, hey, at negative 2, here, because we're decreasing and then increasing, this is going to be a local min. And then over here at positive 2, it's increasing and then decreasing. This is going to be a local maximum value. So I know that I'm going to have a local minimum at x equals negative 2. I'm going to have a local maximum at x equals positive 2. I'm almost nearly done. The very last thing I need to do, I want to know the y values at these x values as well. Remember, this is x equals negative 2 and x equals positive 2. I want to know what are the y values that correspond to these two numbers. And for that, I'm going to look back at my original function, f of x equals negative x cubed plus 12x plus 8. So I'm going to write that down here so that I don't forget. F of x equals negative x cubed plus 12x plus 8. And I'm going to take these two extrema that I found, x equals negative 2 and x equals positive 2, and plug those into my function. So we'll start with negative 2, f of negative 2, let's see, opposite negative 2 to the third power, plus 12 times negative 2, plus 8. Here I'm going to have opposite negative 8, minus 24 plus 8 minus negative, that's really plus a positive. So let's see, this will be negative 24 minus 8 should be negative 16, minus 8 would be negative 8. So this means at negative 2, and I can actually give the ordered pair, at negative 2 comma negative 8, I have, we said, a local minimum. So we have a local minimum at negative 2 comma negative 8. There's my first local extrema. I'm going to do the same thing with x equals positive 2 then. So f of 2 is equal to opposite positive 2 cubed plus 12 times 2 plus 8. Here I'm going to have, let's see, negative 8 this time around, plus 24 plus 8. 24 plus 8 would be 32, minus 24, I don't know why I did it that way, positive 24. So this tells me that I have and we said, in this case, we said we had a local max at x equals 2. So we have a local maximum at 2 comma 24. So the first derivative test is actually kind of a combination of both things that we've looked at so far in this section. It's a combination of finding your critical numbers, which here we said were positive and negative 2, and then determining where our function is increasing or decreasing. This is actually very similar to what we did in our very first video. It's just at the end of these problems, now we need to kind of interpret, okay, if this function changes from increasing to decreasing or vice versa, we can use our first derivative test to help us determine whether we have a local minimum value, a local maximum value, or neither one. Now, one last thing I'll point out here, and you will see this in the next video, please make sure that you are actually testing these values. You're taking your numbers, you're plugging them into your first derivative. We cannot make the assumption that the first derivative sign is just always going to change at these critical numbers or at these partition numbers. We need to go and check and do the work, because if the sign doesn't change, then that's not a local extrema. So please be careful. Don't try and take shortcuts through these problems. Make sure that you're showing your work along the way.